Okay.
All righty. So let me see here. Okay. So welcome to the to this session of the Lunch and Learn. If this is your first time, we started last 2 weeks. We started with our end-to-end machine learning challenge. Okay. And what we're going to do is go through the steps of a machine learning development cycle. I'll show it, promptly there. So you get a feeling, a taste of what is required as a data scientist or, data analyst, even data engineering, how to, approach kind of a real world, situation. Okay. So I'm going to do a review. When we get to the notebook, I'm going to do a review of what we did. But then this session is going to continue exploring that Kaggle credit fraud detection data set. That's the one that we're using. And what we're going to do last time, I gave you a snippet of something called the Pandas profiling report, which is a tool that can accelerate the exploratory phase of your machine learning development project. Then we're going to dig in a little bit more on bivariate analysis when we take two variables. Okay, study especially the target. Study the target with a couple of the variables to see if those variables can be predicted, okay, from the target that we are trying to try to understand. And then a little bit more about correlation, which is in a sum, it will give you a general idea of what the data set it's composed. You have a good general idea then to go to the next steps. So first of all, introductions. So my name is Ricardo. Hi. I've been involved in the Orlando Machine Learning and Data Science meetups in 2019, specifically September. My background is industrial engineering. I work, for many moons ago, I work in manufacturing back in Puerto Rico. And then I'm doing more now real estate, appraisal, personal appraisal, aircraft appraisal, etc. So that's basically me in a nutshell. Ron?
Sure. Yeah, my name is Ron Bergeron. I am currently working as a consultant data scientist. I formed my own company called Adventurous Analytics about 3 years ago, or I guess a little more than that, in 2019 also. Ricardo and I have worked together on a major project that we did with the foster care system here in Central Florida. And I'm currently working on some other projects with a couple different clients. Also, my background also is an industrial engineer as an undergrad, but I have an MBA also, and I've been in various roles across the IT spectrum over my career.
Okay. Any person that this is the first time that you join us in in the Lunch and Learn or in any meetup?
Yeah, hi, this is Nizar.
Hey Nizar, how are you?
I'm getting my video to start. There we go.
Okay.
This is my first time joining. Also, I found out about you guys through Meetup. I'm working towards becoming a data scientist. I'm enrolled in a program called Springboard right now. And been focusing on machine learning mainly, but just everything about data analysis and data science, and it's been very fascinating. I come from a background in medicine. I was in medical school before this, so it's a very big pivot, but I'm very interested in all this and excited to meet everybody here.
Okay, excellent. Welcome.
Thank you.
And any other? I'm going to give priority to the the first times. Okay, so anyone else that is joining us for the first time?
Hi, my name is Matthew.
Hey, Matthew.
I'm a statistician for UCF, and I work on data analysis for medical experiments.
Good.
And then I work more on the mathematical statistics side, but now with ChatGPT and all this AI machine learning stuff, I'm not sure if that's gonna put me out of a job or not in a few years. And so I'm now trying to explore where all this machine learning, AI, ChatGPT stuff's headed to figure out how that might change my job in the future.
All right. Yeah, ChatGPT is in the mind of many of us. Okay.
Everybody.
But let me tell you one thing that I can tell you, from what I have gathered, is that ChatGPT will help you, okay, to be more productive or to be, more, accelerating the analysis or anything that you're doing. But you have to know your fundamentals, okay?
Yeah,
because sometimes ChatGPT spits out some things that they're not correct. Okay, so you have to be very careful on how you use it, and if you don't have the fundamentals, you could be, going on the way to embarrassment. Okay, so be careful with that. So excellent, Matthew. And anyone else that wants to, introduce themselves, if it's your first time.
I can say hi. I'm Albert. I'm a chemist by training, and I kind of miss analytics, and so from grad school. So I just finished a boot camp for data science last month or so. So I'm here to learn more.
Excellent. That's all we're trying to do. Get some, share some skills, share some knowledge, and see, if we can, improve our deliveries. Okay. And anyone else? Anyone else? Okay. Okay. So, one thing that we always, announce in our meetups is that we have a Discord channel. Okay. Before we have a Slack channel, but then we decided to move to Discord. And this is the link. I'm going to post it in the chat when I finish the presentation. This is the link that you can go and, if you don't have an account in that Discord, you're going to create it. And then with this link, you're going to go straight to our OMLDS channel. So I encourage you to use it because we cannot cover all the things that we would like in a meetup, but then in the Discord, maybe we can continue the discussion on some of the things that maybe they were not clear. All right. This is the end-to-end. Okay, just for the for the people that are joining us for the first time, we're using a Kaggle data set. The Kaggle site is composed of almost thousands of data sets and competitions, and you can access freely. There's no charge for it. So we're using what is called the credit card transactions fraud detection. In other words, we're going to try to create a model that can detect from the information that we have in that data set, try to detect as accurate as possible if the transaction is a fraudulent transaction or not. Then we're going to be posting, not right now, but we're going to be posting all our work in GitHub. Okay, so if you're not familiar with GitHub, you should, because this is basically something that any software the developer uses in practice. Then to make it easier for you, because we're using Python for this project, and usually Python is a little bit challenging to create environments, to set up the IDE, etc. So to try to minimize that obstacle, we're using a Google Drive link. Okay, is my personal link, and this is the link that I'm sharing, with your members, and there you will have what is called a notebook, a Jupyter notebook that is already a gear. It's already set up to open in your browser using Google Colab. Okay, Google Collaboratory. So you can follow us up using that notebook, and that's the notebook that I'm going to be using for the rest of the session. Okay. Then, just to make sure that we know what we're doing, this is the development cycle usually for any software development or implementation. First of all, you start with a business understanding. In other words, you are trying to solve a business problem. In this case of the credit card transaction, probably it's going to be a financial organization that is going to have a challenge trying to detect proactively, trying to detect those fraudulent transactions. Then that business understanding translates to a data understanding. In other words, you're going to get a business problem, frame a business problem, and then convert it to a data problem. Okay. So right now, we already, in quotes, we already have done that, right? With the Kaggle dataset, we already have the data understanding. We know more or less, where are we going. Now we are in the phase of data preparation. And for data preparation, you need to explore your data set. You need to do some feature engineering. That's going to be the next session. And then you're going to do some feature selection. Why? Because some of the features in your data set, even the ones that you created, probably they're not going to contribute for the model to predict the fraudulent transaction. We want the best features that have a chance to do a more predictive model. Then we're going to do the modeling. We're going to evaluate each of the models that we have created and then choose one. And that one is going to be the one that we're going to deploy. Usually the deployment could be in a form of a spreadsheet. It could be in a form of getting the data of the predictions back to the database. That's another option. Or doing a dashboard. Okay, and that's where we're going. We're going to try to do a dashboard so an analyst in the organization can load new data and then use the model to try to, from that data, try to predict which transactions are fraudulent for further investigation. Okay. So basically, that's the project that we have. So let me share. Any comments there, Ron?
No, good to go.
Good summary. Okay. All right, so let's get that link going. Okay, that's the link, I think. Let me see. Yeah, that's like that's the link. Okay. Okay, so let me go back and okay, I have my notebook. Let me do the sharing again. Where is that notebook? Oh, here it is. Okay, here it is. All right. All right. So let me give you a quick preview of what we did in the last session. Okay. We started discussing the objective. Usually, you should refresh. Every time that you work in this kind of situations, you should refresh your objectives to try to see if you are going in to that target or not. And the objective, as I explained before, is in this notebook is to perform what is called an exploratory data analysis using that data set of the credit card fraud detection data set from Kaggle. And what we want to do is understand first the data. What is the data? What are the data types? What is the distribution of each of those variables? Are some variables have a constant, value? Because if we have a constant value, there will be no variance, so we can discard it right away before doing any feature engineering. Also, we want to check if there are patterns, to our data set that could be useful for incorporating into the machine learning model, and then acquire some insights. So the first thing that we did Okay, let me see if I'm connecting here. Okay, it's connected. So the first thing that we did was import some of the libraries that we use in Python commonly. For example, pandas, NumPy, matplotlib, and Seaborn. So far, those are the libraries that we're going to be working with. And we read the dataset, okay? And in fact, the first time that we read this dataset, there was a problem with one of the columns that it was unnamed, okay? Apparently, it was a repetition of the index of that dataset because pandas uses indexes for to parse the rows. So we added this index column equal to 0, which is that first column that we got it as a duplicate. And also we parse some dates in advance that we know that those data types are datetime data types. Those are the transaction dates and times, and something that is called DOB, which is date of birth of the customer that is using that credit card. Okay, so when we did that, we do the info.info function, and then we get this, okay? And more or less, we already have some data types that are in the proper type for our analysis. But there's still some ones, like for example, CC number, which refers to a credit card number, and the what is the other one? Oh, the zip. Okay, so the zip code, pandas is viewing is because it has only numbers, is by default is creating what is called an integer data type, and you can see it right there, the D type integer 64. But we know that zip codes are not really integers because you're not going to do any mathematical operation with them. Okay, so what we did was change those two variables or columns to their proper data type, which is object. Okay, is that they're really strings. Okay, which eventually they could become categorical, but for now we're going to treat them as objects. Okay, so we did that. We check if there are no duplicates rows in the data set, right? Okay, and we don't have. From that function, duplicated.sum, we get 0, right? And also we try to verify if there are any missing values. Because remember, some of these machine learning models, for example, linear regression, ordinary regression, and other types that use distance, they don't like missing values. It has to be the data set that you give them has to be complete. So for luck, right? For good omen, we don't have any missing values in this data set. Then we did some descriptive statistics, right? With the describe function, and we transposed that to make sure that we got a more visually pleasing table. And all of these variables are right now, their type is numeric. It could be integer or it could be float, okay, for the decimals. So we have the count, we have the mean of each of the variables, we have the standard deviation, the minimum value, first quartile 25%, second quartile 50%, which is the median, third quartile 75%, and the maximum values. So more or less, these numbers will give you an idea of, for example, how centered those values are or how skewed those values are. But reading numbers, in our brain, reading numbers is not really how we get good insights. Usually we have to visualize these numbers. So one of the things that we can do is, because they're all numerical, right? We can use this quick visualization for histograms, okay? And what histograms is they're going to do is they're going to give you a distribution, okay, of all the values that are composed within those variables. So if we run this, dfraw, the whole data set with histograms, is going to choose, internally the function is going to choose only the numeric ones. because the numericals are the ones that can be inputted into a histogram. So let's run this, and we get, wait for it, okay? So we get those histograms. So let's see that we have, for example, we have something called amount, right? Which is the amount of the transaction that was used, when we use that credit card. So we cannot see all of the bars, but I can tell you from the amount from that particular histogram that most of the values are, grouped into that left side. In other words, it's kind of a right skewed because it has a right tail. So to use it in an ordinary linear regression, that variable has to be transformed. And usually you can transform using log transformation or using other type of transformation to get a more, bell curve shape, okay? Latitude and longitude, which refers to the spatial coordinates for, could be the transaction, okay? We have to figure out that one. Those really have a more bell curve, okay? Even though there could be some outliers, in the edges. The same thing for city population. City population is, when you use the credit card, what the population of that city that we use it. So also is skewed, right? This group right to the left, skewed to the right. Then we have something called DOB. And the DOB is just the date of birth of the customers. To make it useful to our, to our analysis, we need to change those date of birth into ages for the customers. And we're going to do that, but, not yet. And then we have, I'm just picking, a couple of examples. Then we have what is called is-fraud, and that's our target, okay? Is-fraud is a binary variable, right? That it has 0 as a transaction that is not fraudulent and 1 as a transaction that is fraudulent. And it's showing in the histogram, it's showing you basically the bar that has the non-fraudulent transactions. In fact, there is a little bar here, with 1 that is the amount of transactions that we, that in the database were classified as fraudulent. So to see it a little more clearly, okay, that target, which is the is-fraud variable, we have to do what is called a value count, okay? It's a function that you apply to the variable, okay? The variable will be dfraud, is-fraud. And then what we're going to do is that instead of getting the raw numbers, what we're going to do is normalize it. In other words, it's going to convert that count into a percentage, okay? So if we run it, we'll see that the zeros in that variable account for 0.994, 99.4% of the transactions. And the ones which are the fraudulent, which are the ones that we want to, to label, right? To try to predict, is 0.0057. In other words, almost 6%, around 6%, 0.6%, sorry, of our transactions, and there are about more than 1 million transactions here, the data set, around 6%, less than 6% is fraudulent. So this is going to be a challenge because this data set, the class, the target, is highly imbalanced, okay? When we talk about imbalance, we talk that the majority group basically has all the, all the rows, right? All the observations are in that group. And then we have a minority, which is the fraudulent right now, that has a small, percentage of that. And it's going to be a challenge because for machine learning models, they tend to get biased to the majority, not to the minority. So we'll have to explore some techniques in the modeling phase about how to balance more those observations, okay? So any questions so far? That's basically what we did in the first session. Okay, so the first topic that I want that we want to explore is how did I create that report? Okay, that is called that it comes from a package, a library called Pandas Profiling. Okay, so the first thing that you have to be careful with, the analysis that we want to do is that some of these libraries expect a reasonable amount in the observations of the data set. In other words, they cannot handle that many observations, and Pandas Profiling, has that weakness. Okay. Okay, you want to do? Okay, sure. Let me go zoom here. Okay, well, no incognito. Okay. Okay, is that better? Okay.
That's good. I just wrote Ricardo.
Oh, you just wrote it?
Chat that,
okay.
That it was, the text was a little bit small, so
small.
Hopefully that
okay.
enlarges it a little bit for everybody.
All right. So Pandas Profiling expect, for example, it can handle maybe 1,000, 200,000, 300,000 observations. After that, it gets really sluggish. Okay. So one of the things that we have to do is that we have to sample that DF underscore row data set. But we're going to sample it in a way that we don't alter, right? We don't alter this distribution in the target. Why? Because you want a sample to be representative of the population, which is your whole data set, right? So this function called group by is going to help us to sample observations that in the result, we are going to have the same distribution in the target that we had in the original data set. So what we're doing here is using group by the target, right? So we're going to group by the target. Then we're going to say group keys false, okay? Because that we need it to be false to then apply what is called a lambda function, okay? And a lambda function is kind of an anonymous function that you are applying on the get-go. So in the lambda function, we're saying that for x, which are the observations, right, from the data set, we're going to apply the sample function, and we just want a fraction of it. So, picture in your mind that the whole data set is 1, right? So if we say fraction equal 1, that's going to be 100%. So fraction 0.3 is going to be 30% of the whole pie, right? And of course, we want to replicate this. So we're going to seed it with a random number, and that random number is going to be 2019, but it could be any number that you choose, as long as it's the same, it's the same number that you use for reproducing your sampling. Okay, so when we run this, we're going to get what is called a stratified sampling. So we're stratifying by the target. So we can maintain, we're trying to maintain the same distribution here. All right. So now we have 389,000, which, is in the threshold of Pandas library, right? And we want to check again the that ratio, right, of the target. Okay, so we're going to run the same function, value counts, normalize equal true, and let's see if we get more or less something similar to what we got here. Okay, this this number that they don't deviate that much. Okay, so let's see. And we got, okay, the numbers probably are not the same. Let me see if they're the same. Yeah, they're the same. Okay, so we have the same distribution in our sample for the target that in the original data set. So this example is the one that we right now are going to use for our analysis. Why? Because it's going to speed it up, right? And now we can, with this function, right? Pandas profiling, these are the instructions to install it into your environment. But this is the function from Pandas profiling, import profile report, and then from Y data profiling, import profile report, because they change the name of the GitHub repository that the source is. They change it from Pandas to Y data. I found out the hard way, of course. And this is the function that we are going to run. I'm not going to run it today. Already run it. This is the function that we are going to run to then get the report in an HTML file. And this is the report that we have. Okay, if you run that in your notebook and you save it to an HTML file, this is the result. Okay, so this one is going to give you a lot of the analysis that probably you should have done manually, but it's going to give you a boost because it's going to be only 1 or 2 liners, and you're going to get a lot of information. So in the overview, it's going to give you the number of observations. Remember that we use the Pandas profiling report creation. We use the DF sample, okay, the sample of the original data. So this is the number of observations, the number of variables, how many are daytime, which are right now there too, right? Transaction time and the OB, date of birth. Then you have 9 numericals, and 11 that the report is classified as categorical, but usually you are going to see them as objects. Okay, so just as the first glance, transaction day, transaction time. You get here the minimum value and the maximum value. So this data set is a collection of credit card transactions that transpire from January 1st, 2019 to June 21st, 2020. Okay, so we already have the range of the dates there. And this is the histogram of the distribution of those dates. As you can see, well, let me ask you, do you see anything, odd in this, in this plot?
Is it that there's a rise in a number of transactions in that period of time?
Right. There's kind of a spike, right? You see all these transactions that are kind of in the same level, right? Okay, if you follow my mouse, kind of in the same level here, but then there's a spike. So that spike, we can, assume that because it's at the end of that year, 2019, right? Okay, we have 2019 here, and then 2020 begins. That could be a spike of the transactions done on Christmas season, between Thanksgiving, Black Friday, and the Christmas season, right? But we can, go deeper on that in terms of how many transactions were done, in a month and within a year. Okay, so we can, pretty sure find out where was those transactions, and if that helps, the thing is that does that help to identify our target, the fraudulent, right? Okay, then we got, let's see here, we got some categories here. Okay, so in the categories, you have the top ones, right? You have gas transport. In other words, most of the people that use the credit cards use it for gas or for any transportation needs. Then you have groceries, right? Then you have home, items, shopping, etc. But if you want to get the whole detail, right? The whole detail, then you can go in more details and you can go categories, and it will give you, more detail there. One of the things that when I approached this data set for the first time is that I noticed that there were some transactions that have underscore net at the end. and the other ones, they don't have it. So one of the things that, and it was discussed in the Kaggle site, is that these transactions of the shopping.net, or there's another one called groceries.net, etc. Those are online transactions. So we can assume that if they don't have a /net, there could be transactions that they were done physically. In other words, you went to a brick and mortar and you use your credit card there. So one of the things that we can, analyze here is, okay, if I separate those categories, okay, between brick and mortar, physical categories, and online, am I going to get a good variable that can predict if the transaction is fraudulent or not? Maybe yes, maybe no. But that's something that is, kind of, reflected by these categories. So these categories have to be, further analyzed. Okay. You have the amount, right? And you see the amount when you go to details. You see this skewness, value. Okay, and usually the skewness for a bell curve Gaussian distribution, and maybe Matthew, can, validate this, statistician. Usually the skewness is between minus 0.5 and 0.5. Okay, that's more or less the skewness of a bell curve. If it goes more, in either direction, less than negative 0.5 or more than 0.5, then we have a skewed distribution. And here we have 55. Also, that means that there could be the presence of outliers, okay? Transactions that really go way out of the, of the main pack of the values, okay? And so that's something also that we have to, investigate, okay? Okay, so we have the first and last name of probably the customers. Question to the group. Do you think first and last name will be, a good variable to predict the frauds?
No, it's also probably, private information that you might want to get rid of.
Correct. Okay, so yeah, I think the same way. First and last name, I don't think it's going to be the, a great predictor. Let's put it that way. Okay, but I may be wrong. Maybe there's an association between some customers and some fraudulent transactions, right? So that, but I agree with Albert that probably that won't be a good variable, to maintain. You have the gender, right? Female or male. Are females more prone or males more prone, to suffer some fraudulent transactions? We have to investigate. Okay, because right now, at least you have more females than males here. Okay, so we have to investigate that. You have the street, the address, the city, the state, the zip. That's the address, I presume, of the customer, right? You have the latitude and longitude. We still don't know what does that mean. Does it mean the latitude and longitude of the customer, or it means the transaction? I kind of go with the transaction, but we'll find out. Okay. You have the city population. You have what kind of jobs. Okay. Those customers are, and it's very what is called is very it has a high cardinality. In other words, the unique values of this variable is 494. So we have 494 different labels for a job. Maybe that will be useful, maybe not. Okay, we will have to see, what we can do with it. Date of birth. So date of birth, what we can do is transform it, instead of a date, we can transform it to the age of the customer. And maybe the age could be useful for analysis. You have transaction number, and that transaction number is just an index. So we have as many values, unique values in transaction number as the observations that we have. Probably it won't be a good predictor. There's no, it's just uniform, right? Then we have some Unix time. And the Unix time really, it was one of the questions that I posted in the last session, the Unix time is the number of seconds that have elapsed from January 1st, 1970, where supposedly that was the creation of the C language, and the Unix system is programmed using C, and then the date. So to convert that to a date, what we have to do is, just, count those seconds and then transform it to a date. But seeing that distribution and comparing with this, okay, I don't know. I have the feeling that that variable have more or less the same information as the transaction date and time. I could be wrong, but this is my first insight there. So we have to see if that is something that we want to keep. Then we have the merchant latitude, the merchant longitude, and we have the target that is in balance. Then we have some interactions here, okay? And unfortunately, Pandas profiling has not revised this, okay? It's not the best visualization, to try to see if there's a linear or if there's a curve, a shape in between different variables. So let's pick one. Let's say that we want to see city population, right, by amount. Okay. Wait a minute. City population amount. Okay. And as you can see, although there's a relationship, let me do this backwards. Okay, city population and amount. There has to be some kind of relationship, even though it's a random relationship. But right now, this interaction doesn't help us because they're using those hex, that's hex geometrics, and it's not helping. There's another library that is called data prep, and that data prep gives you more or less the same information, but in the interactions, it uses lines. Okay, uses lines and points here. So interactions is not going to help us that much. Okay. Let me see. All right. So we are now entering the correlations are real. And this is very important because here is the first time that you can see what is the relationship between your target and the other variables in the data set. And if you point to this line that I'm trying to get here in the with my mouse, this line which is fraud, that means, let me do the Pearson, okay, because it has the auto here. Let me do the Pearson here, okay. So this is only the numeric variables with correlated with each other and also with the target. So is fraud, the amount and is fraud is in this area, okay. It doesn't give you the correlation number, but it's going to be between this area. And this is the one really that sticks out, right? Because the other ones are less in that zero zone. So amount and is fraud apparently has a more correlationship than the other variables. The other one that I want to, that you can appreciate is that latitude and merchant latitude is almost 1. Okay, so the latitude and the merchant latitude are basically the same information. Okay, and we can explore it in a scatter plot. We can explore it where you're seeing that it's going to be a straight line to them. So what we can say is that latitude is really the merchant. In other words, when you use that credit card, the merchant location was the one that was retrieved from those coordinates. Okay, and we can see if there is we can convert it to a distance, right? From the city and the address, we convert it to a distance and then see if that distance really is a good predictor of the US fraud. Okay, because right now with latitude and longitude, we only can visualize it. But to use it, we have to manufacture another or engineer another plot. Okay, so here we have the Pearson, which is the numeric, we have the experiments, which is ranking, okay? And also we have that amount, and we have also the merchant latitude and merchant longitude as basically the same information. Then you have the candles, which also is a rank, but it's a different type of calculation for the ranks. You have the phi k, which is a matter of not correlation, but of association. And one of the things that this correlation gives you is that apart from the numeric, also it gives you categorical data, okay? And also the Kramer's also works with association, and it gives you, the association between categorical data and, the target or within themselves, okay? We don't have missing values, and this is a sample, okay? First rows and last rows of the data set that we're using. All right, so we can unpack a lot from this report. One thing that I wanted to do, but I don't think we will have time, okay, is to hone on these interactions, okay, because the report is really, the visualization is really poor. So one of the things that we're going to do for the next session before entering into feature engineering is that we're going to explore more about the relationship between the target and the other variables, and some variables that we're going to create. For example, age is one of the variables that we're going to create from the date of birth. Okay. Any comments? Any questions so far? What do you think of the report? Do you like the report? Because usually, go ahead.
No, yeah. So I'll add my 2 cents in. Yeah, based I think it's a quick and a nice and quick way to get to a lot of summary information about the data set, and gives us a quick glimpse at where to start digging further.
Mm-hmm. As a matter of fact, I didn't show you, but also it gives you some alerts also. Okay, if you go in overview and you press the second tab, it gives you, for example, variables that have high cardinality, in other words, that have many values within them, and also high correlation, which could be useful because when we went to the correlation heat map, we checked that the latitude and the longitude were very highly correlated with the merchant latitude, merchant longitude. But this one also has it here also. Albert, you want to say something, I think.
I was going to ask if you could go over quickly on the correlations. The difference between, you said that the phi k is association?
Yeah, the phi k uses an association, formula. Okay, it's not really the correlation that is used in the Pearson or the Spearman. And the thing is that they are not equivalent. For example, the association between is fraud and let's say amount is not going to be the same as amount and is fraud. Okay, they're not symmetrical here. Okay.
Okay, thanks.
Yeah, I mean, it is something that you could use, for example, to try to explore associations between categorical variables instead of the numeric. Okay. It could be useful. Maybe it's something that is not that that straightforward. Like in the Pearson or even the Spearman, that we know more or less where the values are coming from. Okay, the only problem is that in these three, the Pearson, Spearman, candles, they have to be numeric, the variables. They cannot be a label. Phi k and Kramer's can use categorical. Okay, they accept categorical inputs.
Sounds good, thank you.
Okay. Okay, so we're approaching 1. So next time, what we're going to do is wrap up the exploratory data analysis because we want to move forward, right? But we want to explore certain relationships between the target and some of the variables that we could presume that are predictive or not. And we're going to do it visually, but also we can do it using hypothesis as testing too. Okay.
Ricardo, I'll ask
Yes.
a quick question. So
Sure.
with this pandas profiling, is this something that you would just use to get an idea of what kind of analysis you would do later, or would you actually include this in, a report that you're putting together if, like the bigger project?
Okay, my answer is both. Okay. Because for example, let's say that you have with the project, you have follow-up meetings, right? Follow-up meetings with your clients, with your stakeholders.
Sure.
So maybe the first follow-up meeting that you want to do is explain to them what are you finding in the data that you're collecting.
I see. Okay.
And this report can really help in that.
Yeah. And this is a classification type problem. Would you also use it as a regression, something that you were estimating a certain value instead of?
Okay, because that's a good point, because this is a classification problem. The target is a categorical variable. We can use logistic regression as a baseline, right?
Yeah.
Okay, we can use logistic regression, which is not, it has the regression, last name, but it's really classified.
Yeah.
Okay, it's really classified. But yeah, you can use logistic regression for your baseline, and probably will use it. Because the good thing about the ordinary regression or logistic regression is that because they are very transparent algorithms, you can understand a little bit about the interactions of the variables and also which are the important ones, okay, from the coefficients, etc.
Okay.
So it's always a good tip to start with base models. Base models that can give you a baseline, and then you start improving with more complex models.
Would you ever, after feature engineering, some new features, would you come back and use this, or at that point, would you just do it on your own?
Probably not.
Okay.
Probably not. This is kind of a snapshot, okay? For what do I have? Once I start using the feature engineering, start doing the feature selection, you could do it. You could do it as a conclusion report, right? Okay, this is the snapshot of what I created. But in reality, I haven't used it that way. Okay. I use it at the first shot.
Yeah, makes sense. Thank you.
Yeah. Okay. And also, it could be the problem is it could be confusing, to try to explain, because then you have to, go into the details of what are the other features that we're creating that are not in the original, data set. So it could be kind of confusing sometimes. Okay, so Lee.
Hey, Ricardo. Hey,
Yes.
sorry I missed the past two classes or the sessions, but I see you're recording it. Is there a way to get access to the other two recordings, or even this one, just to catch up?
Okay, we posted our first recording in the Discord channel.
The link to it's on a YouTube channel, but the link is also in Discord.
Okay.
Right. It's in Discord, but we have a YouTube channel also. Ron, could you post later that link to the?
I will.
To the YouTube?
I'm gonna get it. I'm gonna get it right now.
Okay.
Okay. Yeah, that gives me a chance to catch up a little bit.
Sure. All right. All righty. So I think that's a wrap. Thank you for your time. I know that this is lunchtime, so thank you for your time. And probably we'll do another one probably in the next 3 weeks. Okay, because we have to prepare, a good show for the feature engineering. but we're going to start with the, with some analysis first of varied, kind, and then we'll try to follow up with the feature engineer. All right. Okay. So
Thank you so much.
have a great, rest of your day, and we'll see you later.
All right. Thanks, everyone.
Take care.
Okay.
Thank you.
Bye.